This second task in handout is also big and physical, and it's big and physical because that's how they'll remember it. They'll remember lines and how they first encountered them, or at least how they encountered them in your class. As for what the three recipes are going to describe, well, A describes all the points that are equidistant from 2 points. So if I have 2 points, that would be this line here. B gives us more or less the 2-point formula in that it describes all these points here. And C is kind of a point slope definition of a line. So we're going across and up, well that gives us a slope, and so it doesn't matter how much across, as long as we go the same ratio up, we get the same point slope definition of a line. So they're all actually 3 different definitions of a line. I know some people, including my daughter, will quibble with the way this question's been asked, but it's kind of deliberate because that's life. That's how questions get asked. They're not always asked in the right way. It's important to have a flexible mindset to be able to sort of wrestle with that kind of thing. As for recipe D, for those students who've mastered the other ones, that's actually going to describe a circle. Now, seeing that it describes a circle is not nearly so quick and easy, unless you've done Pythagoras' theorem. If you've seen Pythagoras' theorem, it's actually a lovely little quick calculation to figure out the loci of points. Because scale isn't going to matter to the shape of the object that we finally find, your initial gut might have been to put a point at 0, 0 and a point at 1, 0. I'm just going to tell you, with the benefit of hindsight, that putting a point at 0, 0 and a point at 3, 0, the algebra all works out much nicer. Anyway, if they have seen Pythagoras, great little example to work through. But even without Pythagoras' theorem, you can sort of say, well, there's going to be a point that's sort of here, and then there's going to be another point that's out here, and you can just find a few points where it's actually going to work. You can help guide them to seeing that it might actually be a circle. But there's no reason to know that it's not going to be an ellipse, for instance, or something else. Even if they haven't seen Pythagoras' theorem, you should be able to see that you can't go off in any specific direction. Because if you tried to go off in any specific direction, say you were a long way away from these 2 points, well then the distance between this point and that point way up there is going to be roughly the same as the distance between this point and that point way up there. So this one could never be twice as big as that one if the point's far away. Right, that's sort of a hand-wavy thing, but it actually is a good sort of hand-wavy thing to have your students wrestle with if they haven't seen Pythagoras before. Otherwise, have them do the Pythagoras calculation. It's a simple one, and it's pretty gratifying to see all of a sudden that out pops the equation of a circle. Right, have a go at it all.